Welcome to the first tutorial of the Contam 3.2 for home air project. So we are going to talk on how to create a simple zone for the project. Uh, the screen you see over here is a enter screen for Contam, and the black cursor is the cells which are present in the Contam. The Contam screen consists of various cells. So yeah, there to draw any walls or elements, you have to work with the cells.
Are they predefined dimensions?
There are no so Contam is not a dimensioned software. To define any dimension, you would have to count the number of cells and draw it based on the requirement. However, you can still modify the area and the heights even though you have defined the cells. So the cells are essentially only for a shape.
Okay.
Before we start our project, we would have to set what kind of units we require. So to uh, set the units, you have to go in view and project options. This would determine if you want an SI or an IP units and your default zone temperature. So this would be your set point temperature and your units of flow. Second is the sketchpad dimensions. Uh, this would determine the number of cells. So if you are considering one cell as 1 feet, then you might have to increase or decrease based on your requirement. And okay, so once this is done, uh, then there are 4 drawing tools present in the Contam: walls, boxes, ducts, controls, and these are the delete options. So if you have a simple box, it would be better to create a box by clicking over here. The pink tool is the drawing tool. So if you have a pink box, that means you are in the drawing mode. To create a rectangular shape, you just have to click and drag the box and click at the end. This would consist of all your 4 walls. And similarly, to delete it, you just have to click your box and click or select the region. And so once the box is selected, you have to press delete, and depending on what stage you are, you can select what you want to delete and press OK. And if you have an irregular shape, you can select wall, and then once you click and you move in the direction you want the wall, on the bottom left you have number of cells you want to select. So maybe let's say we have 20 by 20, so we select 20 by so while creating a wall, you cannot stop in between or click at the end of one direction. You just have to move your mouse based on what direction you want. So if I'm at the end of the wall, I just have to move in the direction I want and not click it. So maybe we have something like this,
Yes, perfect.
and when you are at the end of your junction, you just click it and your walls are created.
Okay, good.
So once your walls are created, uh, the second step would be to determine its heights and determine its floor area. So to determine the heights, you have to go to level and edit level data. So uh, this would be the number would be your floor you are at, units, and you can even give an elevation to the uh, your room, or distance to the level above. And you can create multiple floors if you have. So right now we just have one floor and height of 10 feet,
Sure.
and you have to press replace to do the height and press cancel. So currently the room height is 10 feet with the area. And once that is done, click on any region inside the zone, right click it and press zone. So all your zone specifications would happen in this brown box. And to specify it, you have to double click it. And now even though you have mentioned your cells would not automatically calculate your area. Your floor area would have to be entered into this. So maybe we say right now it's around 400, and your based on your height, your volume would automatically calculate. So
Okay.
you can understand what's your height. You have to give a zone name. It would not accept the zone properties without a name. uh, Spaces are not allowed in any names inside Contam. So wherever you are specifying names, you have to make sure you don't have any spaces. uh, Once this is done, make sure you click include the building volume over here, because that would determine your floor area and it would calculate based on your volumes. Uh,
So even though we're modeling, in our case, one room within a larger building,
mhm.
we think of this as the building.
Yes. You could model hallways or other parts including this, and have data separated for both spaces. uh, you can take out results for just one space you want. But if you want to calculate leakages to other spaces and not directly to outside, then it's much better to include some ancillary spaces which are adjoining the study area.
And if you wanted to do that, would you simply go into the drawing tool and draw another rectangle on the outside now?
Yes, so what we'll do
Create it
is
as
we'll
a
do
zone.
okay to this. So this is one zone created. Now suppose we want to add a passage over here. So what, so, and we'll just add the
Perfect.
passage over here.
And you did not close that rectangle on the left-hand side.
Yes,
Was that intentional, or was that it's just automatic?
It's automatic because there's already a wall present over here, so you do not need to create a second wall on this space. So once this is done, you can even define this space as a zone. And your temperature and your pressure difference. So suppose there's a hallway which is at a lower pressure and all your air is going in one direction, so you can determine as a constant pressure, and
Okay.
that would determine your flow. This is one part to determine your flow. Your second would be to have a flow arrow, and that would determine your leakage area flow.
Okay.
This is like the zone pressure and temperature, which is usually variable. So suppose we have some value, and uh, we would come to this after we have set up different species. So once you have set up different species, you can select those and set up an initial concentrations of those species. Like CO2 would be at least 400, or it would not go below 400. So you can set up saying that okay, it would start from 400 and not from 0. And this is usually more for a CFD. We would do a normal zone and scheduling. So this is more for temperature. If you have varying temperatures in daytime and nighttime, so you can set up a schedule to have a different temperature. To do that, you have to click new schedule and do a new temperature schedule.
Mhm.
And put in your values over here at different timings. So we have 75 at this and maybe 72 at night. Sure. You can have your temperature graph over here to understand your different temperature schedules, and you just have to replace with the existing day schedules.
Okay. Other room.
Yes. If you have a constant temperature which is not varying, you might not require to create a temperature schedule because you have already set a set temperature over here. So this is your temperature which is being maintained throughout the day. So once your zone is set, second would be to model your windows or your doors to other zones and the ambient. Right now, the outside spaces is considered as ambient. So if you have any flow component towards an external wall, it would consider it as an towards ambient spaces, and any flow component towards any zone is between those two zones.
Mhm.
So to create a flow component, you have to click anywhere on the wall and right click it for a flow path. So this would determine your flow in this wall, and double click to open it. Uh, you have to first do a new element, and there are different airflow elements and different methods to determine what kind of airflow you want.
Mhm.
Uh, for our purposes, we could do a leakage area if the window is not an opening model. So we would do a leakage for windows. Suppose you have a window 1 per unit length. So based on the length, it would calculate your, and then you can determine your pressure differences and the flow exponent based on what's in what direction you want your leakage to go. So if you have from exterior to interior, you want the pressure difference in the positive. If you want from interior to exterior, you want it to be negative. And then we do a small opening in case of a leakage area. uh, you can, once it's done, you can still go and edit the element to make the changes in that particular element, particular airflow path. Then the direction, so what is the direction of your airflow? So we would have from ambient to bedroom. If it's saying it's negative, it's coming from outside. And in case of air conditioners, you can set up your filters, but for these leakages you might not require a filter. And in case of a window, if you have an opening, you can create a schedule for how many hours you want that to be open based on the data.
Okay.
So once your path is set, you can create multiple for between the hallways as a door or for the windows. So this would determine your connections to the ambient and to the other spaces. Uh, Next component would be we would set up different species based on measurements we are taking. We go to data and contaminants. So to create a new species, you have to click new and have your name set up. So we have ozone as the first species. You might have to fill in all the required data based on the properties. So right now I'm just filling in the molecular weight. The non-trace contaminants would be for something like water vapor, where you just uh, calculate your humidity, and you'd have to do using simulation so that it's calculating it. You can even set up the default concentrations if you know some minimum concentrations would be present in this space. If you can add a default concentrations over here and even add in the zone, that would add up to the concentration. So make sure it's mentioned at one place. So we have one species mentioned. Let's add one more. So we have two. So we have two species right now done in the space. So to add the contaminant data, you have to double click the zone area. Now you have both the contaminants mentioned over here. In this case, you can set up the values in ppm, but I'll explain later how you can set up the ambient concentrations, and that has to be determined in the kilogram of the species divided by the kilogram of air units. So let's say we have 400 as the not for CO2 we have 400. You can also add a kinetic reaction by clicking new reaction over here. Name of the reaction, so this is your reactant species, and your product species would be something like formaldehyde or any VOC. Adding the reacting coefficient, and this adds your kinetic reaction to generate a third product species from one to the second. This way, many kinetic reactions can be added as a minimum. Okay, so once this is done, this is the entire zone, and then next is to model your air handling systems. So we have to model your supply ducts and your return ducts. So first is to open the air handling system, give a system name, minimum outside airflow. I'm giving random numbers over here.
Sure.
Just for getting some data. If you know that contaminants are gonna come from outside, so you will have to specify in the supply and the return, not over here in the air handling systems. Your schedule would determine how much outside air or timings are coming, and similarly, if you have a filter which is stopping any contaminants like for ozone, so you'd have to add a new filter for that. So once your system name is set up, you'd have to go to the supply, select the system from here. This is your design flow rate. So in the main HVAC, we determine how much is your outdoor air. Over here, how much is your CFM for supply, and similarly for schedules or filter if you have any in the supply. And for the return, select your system over here. And so your systems, your zone, and your flow paths are set in the space. Next is we would model sources and sinks to determine different materials.
So can you, okay, so you did the air handling unit itself, a supply duct and a return duct.
Mhm.
In most bedrooms, for example, you would not have a return duct. You just have the supply duct. If you did not include the return duct, would that work, or do you need a return duct somewhere?
It would work. So in case if there's no return duct, the only place the air could go out is the leakages or the windows. So your airflow would determine based on what's
Okay.
yours.
So if you're modeling the room in the hallway, right now you don't have a door to the hallway, so
Yes.
there's no connection. But if you added that door to the hallway, it would have a natural leak underneath it,
Yes.
and it doesn't matter that the return for the house
Yeah.
is a room away. It would know to allow air to go out underneath that door as well as through the window.
Yes, you can even put a schedule for opening the door, so it's not just through leakages. You can even
So can you delete the return air duct, since you probably wouldn't have one in the room?
yes. So in case to delete any element, you just have to click on the element and press delete. So that would be same for any flow path
Right.
or zone.
Can you go ahead and add a door to the hallway then?
Yes.
That's good.
So we have a flow path. Open it. We add a new element to it, and let's do one opening. It's a two-way flow model, or we can do a leakage area, same for the door. And you can have two different flow paths. One would determine only the leakage area, and then second would be for the door. You can give an opening schedule to the door.
Sure. Okay. And the actual location on that wall doesn't matter unless you are doing a CFD model,
Yes.
because it'll just assume uniform concentrations in the zone.
Yes. Okay. So we have our room set up. We have supply and this. So next step would be for the sources and sinks once your geometry is set up. To do that, you just have to right click it and select source and sink. The C icon is for the sources and sink, so you just have to double click it and create a new element. Now for this project we are doing deposition velocity, so click that, give a name for the element, and
Carpet. Okay.
yeah, and you give your surface area for the entire carpet. So you had 1 square and your species. So you can add some notes for yourself in description in case you want to.
Sure. For instance, the type of carpet.
Yes. If you think maybe you're creating something like furniture, and if you know there are multiple of them, rather than creating multiple sources and sinks, you can create one and add multiplier to it.
Okay.
So once your sources and sinks are done, before that I would also add that annotations is similar like notes. So if you want to add notes to the room itself, you can do that for
And
annotations.
it shows up on the drawing itself.
Yes, so suppose room is small, so it would come up like this and like a note.
Oh, I see.
Star
Okay. So the text doesn't show up by itself.
Yeah, yes, I mean it come when you click it.
Sure. Okay.
Okay. So our sources and sinks are done, our contaminants are set. Second would be to create an occupancy. So to create people, you have to right click it and do exposure. So the smiley face are occupants, and you can determine the occupant schedule based on what location they are. So if they are not present in the space for entire day, you can add a schedule for how many days they are present. And
Okay.
second is the contamination generation. So if they're generating CO2, just add generate contaminants, and then the addition of CO2 would be determined from the occupants.
So it doesn't have a default rate of CO2 emissions from people. You have to specify that based
Yes,
on your
activity or based on how many
Sure.
people. So that would differ based on what activity they are doing. Okay, so occupancy schedule is mandatory to. So at what time they are at what level would be your. So right now I'm saying they're outside, and then at night they're coming back. And you can just select everything and do replace. So once your occupants, your species, and your HVAC is set up, the next step would be to set up ambient weather file and ambient contaminant files. So the next few steps would be to guide through an Excel file. So here we have, so once you have all your measured data based on your time and your PPB, this Excel sheet would allow or help you to create based on per date and time and the ozone PPB. Here I've added two contaminants. One is ozone, one is CO2. So the weather or the contaminant data for Contam is always in the units of kilogram of contaminant divided by kilogram of air. Even though you have your measured data or your data in ppb or ppm, you would have to convert that into kilogram of your contaminant to import it into a weather file. Now this is only valid for exterior contaminants. When you're setting up contaminants inside or using a traceable inside, you can use any units in that. So there is a formula for that. I've given some conversions in the tutorial to convert from ppm or ppb, and the Excel file have has the formula which is directly being converted to molecular air and some air values. So once this is set up, you can directly copy the entire file to Notepad, or you can convert that into a CSV file. So the extension for uh, contaminants is .ctm, and the file contains a header, the start date of the contaminant, the end date of the contaminant, number of species present for the exterior. You can have more species set up as interior, but only few species which are in the ambient. You do not need to match both of them. Your name of the species, so this would list all the names. Uh, this is kind of a personal note to add the units which you had imported and which you are converted, so it's much better to understand the date, time, and the contaminants. Now you could directly copy it. It does not matter if it's spaced or no. Here, if you see, some of them are spaced, some of them are not. So it really does not matter how we are spacing. So once this is set up, then second step would be to set up the weather file. Uh, so you would have to go to a link provided. This link is there in the tutorial book. So this link only opens in the Internet Explorer. Uh, once you have your EPW, or you have set measure data, you could import a EPW, set your start date, end date, first day. This is to know which year is it, and then just create your contaminant weather file. Our second option is create a weather file template. uh, Decide, do your start date, end date, and then this, and then you can create a template and then use that template to modify your data in the weather file. Also, it's a text format, a CSV format, so you can easily create it in an Excel file and then import it uh, into Notepad and modify it. So for the weather file, this is the format is pretty similar. You have a header, you have a start date and end date, your date, uh, date type, and the timing. And this is, I mean, most of the data are over here. Your temperature, your radiation, so all the data are is present over here. Once these two things are set up, or you have your WTH file, which is a weather file, and .ctm, which is a contaminant file set up, you have to go to simulation and do set simulation parameters. Uh, then set some values, like we have a transient flow. A steady state is a 1 day or one particular hour. A transient is number of days. We are doing more than 1 day, so we are doing a transient. Similarly, for contaminants, we are doing a transient contaminant. Your date, start time, and your end time. So your end time would be probably 30. Started once I'm doing for a month. Your weather. So once your controls are set, you go to your weather, you set up your WTH file. So I would go in this, and I have my WTH file set up. I have my CTM file set up, and once those are imported, so this would give you your data from where the weather file is and what it is the contaminant. So make sure your contaminant data is within your weather file. So if these both mismatch, you will not be able to simulate the data. So let's set to August 1 to August 30. That's what my contaminant data is, August 1 to August 31st. Output, keep this at detail, so you have your detailed simulation ready. I would not suggest to change anything over here if you are uh, going in any details. CFD we are not going. Then click run, start simulation. Takes hardly a minute to run for the time step and press close. So this is the result view. When you go to view, you have four modes on. Normal mode is your sketchpad. Your result mode is the one we are seeing. A pressure mode if you want to see. So once you're in the result mode, you have to right click and do plot contaminants. We have two contaminants. Let's look at ozone. uh, so now once you had imported in kilograms per kilogram, now you can view your results in any units you want. uh, Ozone, let's view at ppb since that was our initial units, and then 1st of August. So this is how your contaminant bar, it would give you a graph of all the days. I mean, right now it's just one day, so you can select. And similarly for CO2, we would take in ppm and plot. So it started at setup at 0 and then it went up to 400 within 3 hours. So that's what you can see. So this is one way you can see your results. Second way is go to view, uh, result display. So right now this is at 0. So view and then result navigation last time step. So at the last time step, this is your contamination. This is the second method. The third method is to go to a result viewer. So Contam has a result viewer. Okay. So in this, you would have first save this, and in this, go and open your project. This is my project, and once your project is set, we would go to display options. Uh, Take ozone ppb. You can set your scales, okay, and then play to see. So your colors would, you would be able to see your ppb based on this. You can also use a sim exporter to export your numbers to a csv format, which can be then imported into an excel file. I think that's it. So we have covered most of the things, and for more details, you can refer to the tutorial file attached this, and also there's this uh, example file attached, and other example files which have been attached with this tutorial. Thank you.